there, Mr. Sutton here, bringing you the AB Calculus 2-6 Extra Practice number 8 solutions on continuity. There's a puzzle that goes with this. Let's go ahead and look at that. So here's our puzzle that goes with that extra practice, and they're saying that this is going to be a conversation between sine of x and tan of x, and apparently the conversation is whatever you fill in with these blanks down here. It's going to work out to some kind of back and forth conversation. So the way that this one works, there's a few parts to this. We have these 8 different functions that they're giving us here, and they want us to do 2 things with each function. For part A, they want us to figure out the limit as x approaches 0, and we're going to pick from this e through y bracket of answers here. And then for part B, they want us to match it with a graph. So this is less of a calculus question and more of a just can you use a graphing calculator kind of question for part B. Part A is where you get the real calculus. And now there's also another part to this handout. Down here, questions 10 through 13 are asking about which graphs have certain properties, and there's a few to choose from in choices R through Z. But these are graphs that were used up here anyway, so you can still use the pictures up here if you already know what matches these to help you answer these last few questions. So with all of that said, let's go ahead and get going on this puzzle. All right, let's get going with question number 1. Now you might have noticed that I'm temporarily skipping number 1 part A. I'm going to do part B of each of these questions first, because I think if we can identify which of these graphs this function is associated with, finding the limit as x approaches 0 is going to be much easier. I'm just going to have to look at the graph. I'm not going to have to do any kind of algebraic analysis. So let's go ahead and take a look at f of x equals absolute value of x. I already know what this one looks like, but I'm going to go ahead and show you on the grapher anyway, just so we can get the hang of using that. So here's my graphing calculator. I'm going to go to my y equals, and I'm going to just clear out anything that is already in y1, and I'll put this function in there instead. So to get absolute value, there's a few ways to do it. I'm just going to do, let's see here, math, and then if you go over to num, the very first option is abs, that's the absolute value. There's a faster way to get it, but we're not using it enough to really need to do that. So I'm going to put x in there. And now I'm just going to do zoom 6, get a standard window that goes from 0 to 10 in every direction. And there's my absolute value function, looking like a V, just like I knew it would. So that is going to match up with M. So we're going to put an M in spot 1B. Now you do have to be careful because some of these are repeated. So let's see here. We have a 1B over here. And where else is there a 1B, if anywhere? Going down to the second row, there is a 1B right here, so put an M there as well. So we get to use that one twice. For 1A now that I've identified this graph, I'm going to find the limit as x approaches 0. So as I approach 0, which is at the origin here, from the left and the right side, it's coming out to the same number. We're approaching the y value 0 there. So that means that my limit is going to be 0, which is choice E. So let me put that in 1A, wherever that is. 1A, right there. So there is an E. And are there any other 1A's hiding in here? Nope, I think that's it. On to the next. Next up, let me figure out for part B of number 2, the graph of 1 over x squared. So I'm back on my graphing calculator in the y equals. I'm going to actually do a fraction mode for this. So I'm going to do alpha y equals, and that pulls up this little submenu. This n over d option, if you press enter on that, gives you fancy fraction mode, which I'm going to use for a few of these problems. So we'll do 1 over x to the second power. There's my second power. And let me do graph. And that gives me this kind of thing where we're approaching the y-axis from both directions and kind of going up forever. So that matches up with A. That's the closest match. So I'll put that in spot 2B. So there's a 2B right there. And here's a 2B over here. And if we keep going, I see no more 2Bs. 2B or not 2B? That is the question. So on to part A. So given this graph of 1 over x squared, what's our limit as x approaches 0? Well, as we get closer to the origin, from the left and the right in both instances, our y values are going up forever. So that would be a positive infinity, which represents letter O here. So I'm going to be putting an O in 2a. So here is a 2a right here. And we've also got a 2a down here. And I think that's it for the 2a's. Here we go with our next function, absolute value of x over x. Let's see what this one looks like. So here we are in the y equals. I entered all that in there using fancy fraction and the absolute value thing that we saw earlier. So let me do my graph here. And it looks like we've got two horizontal lines that have a little bit of a jump at the origin. So that looks most close to this graph O right here. So it looks like 3b, wherever that is getting an O. So here's an O for this 3b. And is there another 3b? Yep, right here. And any more 3b's? Oh, there's another one. We get 3 of them. Nice. And I think that's it. For the follow-up question, the part A actually, limit as x approaches 0. Well, as we approach 0 from the left, we have a negative y value. Not really sure what it is, but that's what it is, whatever that y value is. And as we approach from the right, it's a positive version of that, positive y value. Since the limits are different, there is no overall two-sided limit. So no limit, y is the answer to this one. 3a then is y, so there's a y for 3a. And are there any more 3a's? Does not look like it, so on we go. For this next one, we have 1 over x squared minus 1. Let's put that in the grapher and see what we get. So here I am in the y equals. Let's press graph on that. And that's what we end up with. We have like a left, a right, and a center sort of thing going on. Looks like choice D here. So 4b then is going to get a D. There's only one 4b in this whole list of them, and that's at the very end here. Next up, circling back to 4a, we want to figure out limit as x approaches 0 for this thing. So looking at the graph, we're from the left and the right, we're approaching this negative y value down here. Now, what exactly is that negative y value? Well, looking at our answer choices, we have zeros, ones, and infinities, so I think we can narrow it down based off of that. But if you weren't really sure, you actually could try plugging in 0 for x in the equation to see what it comes out to. This will work if it's a continuous function, if the limit and the function value are the same. So if I did have 0 in for x, I'd have 1 over 0 squared minus 1. That would just be 1 over negative 1 or just negative 1, which is what it looks like this could be. So I'm going to go with negative 1. That's L, and that's going in 4a. So there's a 4a right there. And we have, let's see, any more 4a's? Yep, there's one more right here. Now we're going to get really interesting, throw in some trig functions. 1 over x sine of x is our next challenge here. Let's see what that looks like. So I've plugged this into my y equals. Now one thing I want to make sure of on mode right here is that I am in radians mode. For all calculus problems, we should always be in radians mode. And also for my zoom, I actually am going to try zoom trig since I've got a trig function involved. So zoom 7 usually tends to work out better than the regular zoom. So there's what the graph of this one is looking like. It kind of has some sine features, but it's not exactly like sine. So the closest graph that they gave us was this I right here. So I'm going to put an I in 5b. There's a 5b where? Down here, and another 5b right here. So 2 I's right down there. For part A, finding the limit as x approaches 0 of this thing, this is a little bit trickier because the graph, according to the graph, it looks like it's continuous, although none of these graphs have open dots or anything. So there could be a discontinuity. They're just not really good at showing them with the pictures they drew. If you plug 0 in for the x value in this function, 1 over 0 gives me undefined. So it would seem that the function value does not exist, but it looks like the limit exists. We're heading towards the same positive y value as we go from the left and the right. And that's part of why I wanted to look at these graphs. So what y value might this be, even if it comes out technically undefined when we plug in 0? Well, looking at my answer choices, again, there's only zeros, ones, and infinities, or no limit. So out of all those answer choices, I think positive 1 makes the most sense here. And if you think about it, I mean, sine itself can't really get higher than positive 1 just because of the way the function is constructed. So I'm going to go with G, and that's going to be 5a. So 5a, we've got 1 right here, and do we have another 5a kind of hanging around somewhere? It looks like we do not. So it's on to the next question. Next up, let's try out sine of 1 over x on the calculator. So here we are. I think my zoom is still zoom 7, so let me just press graph and see what I get. All right, so that's kind of crazy looking in there. I'm not sure that super matches any of these. I think it might match S. Let's zoom in a little bit. So I'll do zoom, and let me do Z-box, and then let me just drag my cursor over here. I'm just going to zoom in on this middle part to see if it really does resemble what they're showing me in answer choice S. I think it will, but it doesn't hurt to verify. Trust but verify. Yes, we have a whole bunch of crazy lie detector scribbling kind of going on in there. So I'm going to go with choice S. That's going to be 6b. Let's see here. Here's a 6b, and another 6b is over at the end here. And any more 6b's hanging around? Yep, we got one right here. Now we ask the very interesting question, what is the limit as x approaches 0 on this thing? So from the graph, it's kind of hard to tell. That could be like pretty much anything between -1 and +1. Let's go back to the graphing calculator and see if we can zoom in a little closer here. So we'll do, let's see here, zoom, and I'll just do zoom in this time around. And then let me just move my cursor over to the origin, or close enough. So zooming in super close. Yeah, I don't know. That's kind of hard to tell. Let's zoom in some more. Maybe if we keep going. Nope, that's not looking like it's going to be any kind of fun. So let's think about what's actually happening here. As x gets closer and closer to 0, the thing that you're plugging in, the value of this whole fraction, becomes much, much, much bigger. So we're getting up to like 10,000, 100,000, a million, a billion, whatever's above that. And you're taking the sine of all these. Now remember, sine basically just keeps taking you around a circle, telling you all the different y values at different angles around the circle. So if your angle is increasing super, super fast, you're basically just spinning super fast around the circle. If you keep doing that, I mean, you can keep getting larger and larger numbers, and that value of sine is just going to keep changing. There isn't really like a leveling off point where this thing stops and says, okay, I've had enough. So I'm going to go with no limit on this one. This is a weird one, but this is actually a no limit. That's going to go in 6a. We have a 6a down here, and we have another, nope, no other 6a's, so that's it. A lot of mental work for just one thing there. Well, after that last question, now let's hope this one isn't quite so crazy. X times sine of 1 over x, so it's got a piece of that last one in it. Let's see if it comes out just as awfully. So here I am, back on the grapher. I'm going to go back to zoom 7, because my window was pretty crazy from before with all that zooming in I did. And gosh, I don't really see a whole lot of anything. Let me zoom in to the origin here. So zoom in, origin. Let's see if I can get a better look at what's going on there. Okay, we've got a little bit of zigzaggy stuff. Let's zoom in again. And maybe this will give us a better picture. Okay. Yeah, that definitely is looking like U. Looks like more like that than any of these other things. So 7b, then I'm going to go with U. So there's a U right there. And do we have any other 7b's? We do right here. There's another U, so the word U and the letter U as well. And that's it for U. Now 7a is an interesting question. Limit as x approaches 0 for this thing. When it was all zigzaggy and looked differently from this. So basically the last question, there was no limit. But here, as we get closer and closer to 0 for x values, although we are still oscillating over and over again rapidly, we're oscillating closer and closer to 0. So this one, I would say the limit is approaching 0 for this. So that would be an E. That's going in 7a. So 7a, we've got one of those right there. And I think we have another one right here, and that's it. Just to round things out, we've got now 1 over x times the cosine of x. Let's see how different that is than the sine version of it. So there's my y equals with that function. Let's do zoom 7, zoom trig, and see if that gives us a good enough picture. So based on the answer choices, I think that this most closely resembles E. Honestly, the only one we haven't picked yet, right? So going back here, 8b then is what I'm going to put that E in. So E there and another E down here. Now we ask the question, what's the limit as x approaches 0? Well, as I come towards 0 from the left side, I'm going down forever. So the left side limit's negative infinity. Right side limit, as we move from the right side, we're going up to positive infinity. Now they do have this answer choice of plus or minus infinity. However, you can't have like two different answers for your limit. If you're going toward different y values, if your limits don't agree, then there is no two-sided limit. So that's going to be no limit y, and that's what we're going to put in a, so 8a right there. And I believe that is it for the 8a's. So now we're on to number 10. Now for 10 through the rest of these, we're using these answer choices here. I still have the graphs displayed so that we can look at them and hopefully we remember which one was which, but we're going with these answer choices. So for number 10, they want to know which graphs out of these 5 selections is or are continuous at the origin. So I think we can eliminate some of these pretty quickly. A is not. D looks like it's continuous at the origin. E, not so much. I looks like it's continuous, but this is one where we saw there was actually like a hole. This was the 1 over x sine of x, so that's actually not going to work out. And then let's see here. We've got M looks continuous. That's the absolute value. O, not so much. We have a jump. S, there was no limit for this one. And U did have a limit, so I think that's continuous. But maybe not actually, right? This was 1 over, or this was x times the sine of 1 over x. So that actually would be undefined if you plug 0 in. So let's look at the algebraic versions of these. This one, R, this was the jump. This one doesn't work. T was the absolute value, and then this other one up here, D, so that seems like it's a good choice. W, you're doing 1 over 0. That doesn't work. X, you have a 1 over 0 going on. So I'm thinking T is our best answer. So let's put that in 10 right here, here, and down here. For 11, we want to know which graphs have asymptotes at the origin. This ought to be fairly easy to pick out. We've got this, which one was this again? This was 1 over x squared. And then this was the 1 over x cosine of x right here. Those are the only two graphs that have asymptotes that we can clearly see. So those are both in W. So we'll put a W in spot 11. So there's a W right there, and I think that's it for 11s. For 12, we want to know which graph has a removable discontinuity or hole at the origin. So it's not A, that's an asymptote. This one here this was continuous. E has an asymptote. I had a hole. And then M did not. O did not. That was a jump. S did not. U, I think, had one as well, though. So we want, let's see here, X. This was X sine of 1 over X. And this was 1 over X sine of X. So X, then, is this one, going in spot 12. And for 13, This one we want to jump at the origin. This one's really easy. There's only one jump, and it's this one right here. This was the absolute value of x over x, so that's an r going in spot 13, right there and right there. Now that we have filled in all the blanks, we can answer the riddle. A conversation between sine of x and tan of x. So this is, I think sine of x is speaking first. Sine of x says, you always go to extremes, tan of x. And tan of x replies, you are so limited. I guess this makes sense because tan has the asymptote, so it does go to infinity, where sine is limited between negative and positive 1 for its range. So, until next time, this is Mr. Sutton signing off.